Hello, everyone. Welcome back to another episode of Human Blockchain Explorers. This is episode number 6, and it's a bit different. This past week, I had the pleasure of speaking in several different conversations with members from the UTXO Alliance, of which Wolfram Blockchain Labs is a member. The UTXO Alliance is helping to advance the UTXO model, and I'll help make sure that phrase gets explained. We're going to do that in several ways. The first is with a video developed by one of our members called Nervos. Nervos is a blockchain based on the UTXO model, and they've really done a great job explaining how the UTXO model works. From there, we'll get a response by the CTO of Topple, another UTXO-based blockchain, and Hans will help answer that question. And then we're going to switch gears a little bit, and we're going to focus on a problem that was brought to our attention from Benjamin Beckman, who is the Director of Infrastructure at IOG. And then several UTXO members will respond to that problem and try and help flesh it out. Each week, we try to bring you an educational, informative, and newsworthy podcast for you to kind of advance your own knowledge about blockchain. I myself am advancing my own knowledge of blockchain, and I'm extremely grateful to have appeared in many of these conversations. So please enjoy this conversation with the UTXO Alliance members.
So what is a UTXO? The abbreviation UTXO stands for Unspent Transaction Output. It is a method of accounting that was created for Bitcoin to allow it to efficiently and securely process transactions that could one day scale to a global level. A UTXO works kind of like this. Let's say you are buying something at the store for $5 and you have a $20 bill. You would hand them the $20 bill and they would hand you back a $10 and $5 bill. You spent the $20 bill. You now have an unspent $10 and $5 bill that you would use for something else. A UTXO is kind of like change in that respect. However, with UTXOs, there is no fixed denomination size since it's purely digital. Instead of handing back a $10 and a $5, you get a UTXO worth exactly $15. If you then wanted to buy something that was $30, you could use your $15 UTXO plus another UTXO, let's say $20, and you would receive a UTXO of 5 in return. There are many advantages of using a UTXO-based system. It is a very efficient way of preventing double spend, an industry term meaning spending more money than you have. Every UTXO has a unique identifier and can be spent exactly once. This creates a provable way to ensure that no one has tried to photocopy a UTXO and use it twice. UTXO systems are also capable of processing transactions in parallel, while the account model used by most other smart contract platforms can only process single transactions at a time. UTXOs are also much more flexible in how a transaction is formed, allowing multiple similar transactions to be batched together to process more efficiently. The result of parallel processing and batching is a tremendous scalability advantage that is capable of fully utilizing modern multi-core CPU architectures and can be performed without sacrificing decentralization.
Very briefly, how do you explain UTXOs to your family and friends, or to your basic developers, or like a category of people that are just need to get the basics? How would you explain UTXO?
I assume you're approaching the question from the direction of understanding it intuitively, and not technically. Because how I would explain it technically is a bit different. But I think the direction that Maud was describing was pretty close to how I would describe it. One of the big challenges when describing UTXOs is because people these days typically transact with card, and so they're more used to thinking in terms of an account model. And so trying to explain to them, harken back to an earlier time where transactions were conducted with cash, and this is what change is, and explaining, okay, so this is this is the fungibility of the transaction. With the $5 that you get back is still $5, and you don't really care. That's usually where I would begin. Um, I find that some of the challenges arise in explaining that the transactions can be split any which way, in the sense that you don't have to have only certain denominations, and you have to pay yourself back with the cash, and so it breaks down quickly. But that's usually where I start, and then and then if I feel like they're getting it, or if they want to understand more, then I think you have to kind of expose a little bit more of the technical underpinnings.
Please, can you do that as well?
Okay, so um, if I would I would have to tailor it based on how technical the audience was, but I'm going to just assume that they kind of have an understanding of what cryptography is, and a basic understanding um, of how cryptocurrencies work in general, in the sense that they're mathematically secured, and that you have secret information that allows only you to spend the tokens that you control. So the idea being that you have some concrete object, which is your UTXO, your unspent transaction output, and you can decide how to spend that. But once it's spent, it can't be spent again, right? You've sort of burned that object. But good news, uh, it's going to create at least one new object. So you get to decide how many objects is this going to turn into, and where are they going to be? Who's going to have control over them? So if you have control of this UTXO object, and you sign it, you approve that it's going to be spent. Okay, great. You can send that to someone, and then they have control over that object, and it's secured by their secret information. If you don't want to give them the entire thing, right? Maybe you only want to give them half, no problem. You create two new objects. One goes to them, and it's secured with their secret information. And then one goes to you, and that's again secured with your secret information, but it's a different object. So that's how you can sort of preserve the change from your transaction.
I like that. Now, looking backwards, you can see the history, but if you're making a new object, then maybe that's where part of the difficulty in state comes from, or what would you say is that difficulty?
I think that's precisely the thing. When you're dealing with an account, you only need to look in one place. You only need to look in the account, and all the state is there. And the challenge that you face with an account-based model is you have to sift through that state, you have to update that state, and that's expensive. In a UTXO model, you don't need to worry about every possible state. You only need to worry about the state that you care about. But you might potentially need to, follow the breadcrumbs of these various objects to piece together that state over time, if you haven't been, maintaining that yourself.
Would you be able to tease out in our technical discussion, and maybe briefly now, like why this is a problem specific to the UTXO model?
The reason for the need for the follower is because the UTXOs are independent, right? You have a whole bunch of coins that are spread across a bunch of UTXOs that you add those together and they make up your account, right? And so you need some active process to keep track of that. What UTXOs do you care about? And I got to be able to find them, index them, preserve them so that I can look them up later. It turns out for dApps, the UTXOs that they care about vary. So if you're a voting dApp, you'll care about voting registrations and governance actions and voting events, things like that. You don't care that Ben bought some coffee. So you can ignore those ones. So you can have a specific follower that's for you. By having a specific follower that's for you, you can tailor your the way that you preserve the data. So maybe a relational database isn't the right thing for you. Maybe it needs to be a cache. It needs to be really fast. Right? Maybe you need to distribute it out to a content distribution network so people can get access to it very quickly. Right? Again, not a relational database that sits back on a node. But currently, the model, I'm going to speak specifically to the Cardano model. The Cardano model at the moment is you run a full validating node, and that node has some accompanying pieces of software that allow you to put transactions in and read data out. And that is a big piece of equipment. It requires specialties in a couple different areas. You have to know what the Cardano node is doing. You got to know how to deal with the database. You got to know how to connect with the database. But that's a lot of work as opposed to calling a RESTful interface that can give you the same piece of information. And so what's the advantage? Do you need the full node with the database and the validator, or do you just call like a Block Frost or an Infura and trust their answers? I think there's a spectrum there. When you start calling those centralized services, you're moving away from Web3, right? It's still blockchain, it's still SSID, stuff like that, but there is somebody that is in control of if your transactions get in. And if you go the other way, now you're in kind of the most trusted mode, but it has those complications that I brought up. So what's in the middle? There are definitely things in the middle. We're not just stuck on the end of these spectrums. And what's in the middle is some type of node that doesn't do full validation and is not centralized. And what's the best mixture there, or what's the best flavor of that node? I don't know. But I think that a community could help pick that apart and probably come up with 3, 4, 5 different types of nodes that fit different use cases. And you lose the centralization because you could place these nodes in the network that could participate directly. You lose the requirement for needing to understand all of that other back-end system. And you could potentially even run these things in your phone. They could be light enough that it's just a process that runs in your phone, and it keeps track of what you want. So now you get privacy. Because you're not telling somebody else what you're interested in.
Perfect. Is this the problem that you're working on day to day? Is this like are you actively trying to build those nodes or do the research on that just for context purposes?
Yeah, so this is one of, we have lots of problems, but this is one of many. This particular one, there are exemplars out in the space of people that are thinking this way. So they're starting to build the libraries to talk to the nodes and the aggregators to collect the information and the event buses to push them out so that you can store them. So there are other people thinking in this way. My goal here is to promote it, get a kind of a bigger set of eyes looking at it, because I do think there's nuance to it. And I also think it's kind of a core capability that once we solve it, it just turns into a process that we run, and you never think about it again. So now we can accelerate the innovation.
Got it. Identifying the spectrum, here's this end, and what's in the middle allows for standardization, and you see that standardization being applicable for all or many UTXO Alliance chains, depending on where the use cases arise, based on they're all trade-offs. But we can assume that there's going to be things in the middle, and can we standardize those so that the innovation happens a bit faster for each one?
Yeah, so let's just think of an example. So I'm going to stay with Cardano. So in a governance system where you're just doing voting, your follower would care about who registered, right? Seeing all the registrations and being able to reflect that back so that when you registered it actually went through. You're also going to want to know that when you vote, that your vote is counted and it's counted correctly, right? It's not put in a different bucket. And then you're going to want to know that everybody else's votes were also counted and counted correctly so that it's not manipulated in some way. So those types of nodes really only need to look at transactions and once those transactions settle in blocks. There is other information that other types of nodes might need. So for example, if you need access to the stake pool distribution, that is another thing that you could have a node that gets that information from some other service, and we have some answers about what that service could be. And it would be specialized for an application that needs access to the stake pool distribution. And then you can keep going. There, like if you need access to the rewards distribution, that could be another type of node that has that capability in it. And so it starts to feel a little bit like a node with a bunch of plugins. You know, I want to plug in the UTXO set, I want to plug in the stake pool distribution, because that's what I need for my DApp. So you configure a few things, you say run, and it goes and does that for you. And then once we get those flavors of nodes figured out, we're also able to accelerate them. So if we can follow the chain faster in some way, we could build that into those nodes, and those nodes can catch up quicker. So for example, if the node knew how to read a snapshot and your DApp didn't need to see things before the snapshot, like particular events before the snapshot, you could grab the snapshot and then just fast forward a little bit. And so something like a light wallet, where you open it and close it and open it and close it, it's possible that you could keep the light wallet closed for a long time. You open it up, it goes and grabs the snapshot from the last epoch or 2 epochs ago, not too long ago, and then just fast forwards from there.
Mm-hmm.
As opposed to going way back to the beginning of time and looking at everything that you don't care about.
So several things I took out of that were Ben laid out the idea of the spectrum of nodes and wanting to discuss something, the 3 or 4 different types of nodes that may be in the middle of that spectrum. Perhaps we could start there, and perhaps I could open the floor for anyone that has an immediate thought. And then if not, I would like to get Michael's opinion considering a time constraint. And maybe let me just pause there and see if anybody has any immediate reactions to what that is.
So I think there is something there, right? In that, I think a feature of UTXO-based systems is that the information is that a human or some actor in the system cares about is often distributed over, fragmented across parts of the system. It's in Ethereum, you have an account, your money is in your account. That's where you go to look for your money. In a UTXO model, it's not that easy. Depending how the information is stored, you don't even necessarily have an index into it. And so we see various manifestations of this kind of problem where someone says, well, I have a particular angle on the blockchain that I care about. I want to look at things that look like this. And now I incur a sort of data processing requirement whereby I need to process the huge fire hose of data that's coming through the blockchain and get the stuff and turn it into something that I care about without compromising security, privacy, availability, resource usage, whatever the constraints that you have. And the system itself does not provide much in the way of us, specialized views into that people might want, not even, like something that corresponds to account. And I think that is a problem for many UTXO-based systems.
So what's not easy about it? Could you expand on that a bit more so that we flush that out so that it can get more visibility?
Sure. So, I mean, even if we think about the simple case, and I very much welcome some contributions from someone else. I don't know exactly how everyone else deals with this, but even if we just think about transaction outputs locked by public keys, the blockchain, certainly the Cardano, the node does not know if you say, what are all the outputs locked by a particular public key? It doesn't have that information to hand. It has, a big listing of all the outputs, but in order to find all the ones that are listed by the key, you'd have to go through it all and find them all. And if you want to know even more information like that, like maybe which transactions created those inputs, that's also outputs, that's also been thrown away. So it's very optimized for the use case of continuing the processing of the chain, but not necessarily for querying the information that is slightly orthogonal to how the node wants to think about it. And it gets even worse if you have more complicated desires, like if you want to, maybe you want to track multiple addresses, or maybe a dynamically changing set of addresses for reasons due to your complicated DApp or whatever. So it's tricky.
And would, along that spectrum that Ben pointed out, could you kind of identify one major one that you foresee as being potential first case of us diving into, or what's like the obvious example maybe that we can use as a way of thinking about this?
I mean, I think the obvious example, and I suspect everyone has this problem, is the example of simply, I'm a user, I have a public key or a set of public keys, and I want to know where my money is, how much money I have, even just how much. And that is a problem that every UTXO wallet has to solve. And many of the other problems are variants on that. One other thing I wanted to mention is, I just thought of, is that things are even worse if you want to know about historical information in the chain. So at least in Cardano, the node only keeps track of sort of what's happening now, the fringe of the chain, so that it can put more stuff on it as it goes. Stuff that happened in the past, you assume that blockchain validates. You probably got it on disk somewhere, but it's not easily accessible or indexable. You pretty much use it to validate the chain, and then you put it away. You don't need it. So if for some reason you care about the transaction metadata on a transaction that was, made a year ago, this is not easily accessible. And making it easily accessible is not easy because there's a lot of data there. So yeah, that's another aspect. One aspect is you want a view on the data that the node has, but you want it in a different form that requires some potentially expensive processing, or you want information the node isn't even bothering to keep, or can't easily or cheaply recompute, and then that's bad for you. And so the example of, someone wants to know how much money they have, that's the first case where the node does have all that information. Although, again, if you want to populate like a transaction history that says when that stuff appeared, now you're asking about historical information, and you're back to trawling the whole history of the chain, which is very slow. So even just that example, I think, is a clear example. And so, for example, in Cardano, the Cardano wallet backend is a kind of specialized chain follower where it looks for your transactions and records information about them that you're going to care about. But it's not easy, and you need to have a full node, etc.
It's interesting. Even in Bitcoin, there are like many different implementation on top of Bitcoin Core that uses different databases and different types of indexes. So they are not equal in searching for historical data, for example. And yeah, so already the first choice is like what type of database and what type of indexes do you use in your full node. And usually at least all UTXO blockchain I know personally, they usually use something on the side for like blockchain explorer type of indexes. And here also you would usually use like some different database with some optimizations.
And those are often usually backed by a full node, right? So you kind of, because you also have to solve the trust problem. And if you're willing to run a full node, then you can suck the data out and put it into a database, and you kind of don't have to worry about the trust problem. But if, like Ben says, you want to say, I want to outsource this somehow so I don't have to run it all on my computer or my phone, now you have a trust problem too, which is quite hard. We've also seen this in Cardano. It's the most popular community project, I would say. There's like 10 different projects which are some variant of a chain indexer, because everyone's like, well, no, I don't want it to be like that. I want it to be slightly different. Or I want it to be faster, but I don't care about this information. Or I want it to be NoSQL because I love NoSQL. It seems like, I think this is something that Ben was gesturing towards, that there's a natural desire to make something that's specialized to people's use cases, but this is also unsatisfying because then you have this proliferation of very similar systems, and it's hard to centralize effort or computational work.
Could we get a bucketing of this problem, like either to put a name on it or to largely define the area of it, so that when you say you have a problem, what is that problem in like a label? Is this?
I don't know. It wouldn't be surprised me if this has a name already. Does anyone come a name for this problem? Well, but the specific one, I don't know. It's like, I don't know, mismatched data access pattern problem. I don't know. I can't think of a snappy name.
I like that. Mismatched. Say it again.
Mismatched data access patterns, because the idea is that your users want to access data in a particular form and scheme, which isn't what the node is optimal for the node, so it doesn't match up, and then you have to do work to translate between them.
Yeah, well, maybe this is why it's a hard problem. It's hard to even, say this is, here it is, the problem. Now, can we put eyeballs on it?
I don't really know. I would also love to know what other people do, both other UTXO chains, and also because, sure, Ethereum, you have an account abstraction. So for the simple use case of how much money does a user have, the chain has that information for you. But for more complicated use cases, like if you want transaction histories or you want other stuff, maybe they have similar problems that relate to trying to deal with the historical information or present the information in a different way. So it may be broader also than the UTXO ones, just that we make it particularly difficult.
The way we try to improve this problem on Alephium, so I always explain this, is like that the account model is closer in terms of abstraction and basics on which building blocks that you build on if you're building an application. It's similar to what you see in the traditional software development space. So if you developed a web app on something unrelated to blockchain and you're expecting information, if you build on the account model, the type of data that you have access to directly from the chain is closer to this. So the developer experience from moving to the traditional, let's say Web 2 or Web 1, whatever, Web 2 to Web 3 is a lot smoother. And this is maybe why smart contract, UTXO-based smart contract blockchain haven't had that much adoption. Because like you said, that abstraction layer doesn't exist at the base level on UTXO chain. What you have is just a list of UTXOs, and if you want to have even basic things as knowing your balance, the application needs to build that abstraction because it's not there natively on chain. But one thing that we tell to people, that we also say to people as well, is that there is an upside to this, is because of this level being really at this, let's say, simplest form. It also brings a great amount of security inherently because it doesn't have those abstraction built in. And it also, specifically if you look at smart contract DeFis and decentralized application, once you manage to solve this problem, it also brings a lot of new paradigm for decentralized application that haven't been exploited just yet, because people in the blockchain, in the UTXO space, we are also within the Alliance, right, fighting to make our tech more visible and showing the way it can be leveraged like this. So we still have work to do, but there are great stuff being done already. And when it is time, I'm happy to talk high level about what we do about Alephium, for example, as well on this.
Yeah, maybe I can add some comments at a very high level. Like I don't have a deep knowledge on atomic swaps, but my understanding is that, well, the name itself, atomic, comes from the atom as the smallest breakable or decomposable piece, and that represents the state. So that's very relevant in UTXO-based chains because the UTXO model has a one-to-one correspondence with viewing the system as a state machine, right? When you have your transaction blocks as a states where nothing changes when it's stored in a transaction. So for that state to change, there has to be transaction outputs that jump onto another state, so another transaction block. So that's not decomposable into smaller pieces. And I think that that's a commonality among most chains in the UTXO Alliance. So I think that we have the advantage that, at least thinking from that perspective, then atomic swaps are very suitable for all UTXO-based chains. And another key aspect of this is that since these are peer-to-peer, these swaps or this exchanges from token from chain A to chain B doesn't require middleman solutions. So, for example, there at some point I've seen in the ecosystem some solutions that required a middleman that would take your tokens, burn them, and then remint them in another chain. So the beauty of atomic swaps is that we do not have to rely on this. So typically we would just default to rely on smart contracts, and these ones are I think that hash time lock contracts that just have an expire date, and basically both parties in different chains agree, and then you can trust the smart contract. I think that that's a benefit. So having said that, or having laid that out, I would like to open up the table for what's the best way to continue on this. In my opinion, it would be to have a discussion about commonalities on UTXO design and try to identify where atomic swaps come handy, and also how how hash time lock smart contracts can be applied. I know that this is the most common way of implementing atomic swaps. So maybe that's a way, or the conversation could go.
All right. So that wraps up this week's episode. And just to recap briefly, what we began with was trying to introduce the UTXO model in different ways. One with a framing video from Nervos, then with a kind of explanatory answer intuitively and technically from Hans Baron of Topple. Then we moved on to a larger problem that the entire UTXO Alliance kind of faces as a group, which is the spectrum of nodes. How do you provide the type of level of information that you need without requiring an overbearing amount of computation? We called that the spectrum of nodes, and Michael Peyton Jones really delved into that kind of idea for us. We heard from a couple of other from the crew, including Alexander Poltrak, Maud Bonwart, both from Alethium, and then Ignacio rounded it out, which led us perfectly into a next step of this kind of series we'd like to go into, which is covering a cross-chain UTXO-based model called Hydra. So we'll be developing that series in the coming weeks, but for now, thank you for tuning in, and we'll catch you next time.